Welcome, everybody. Thank you for joining us for today's webinar, Piston Alloys and Coatings. I am Amanda Harmoning. I'm an admin assistant here at AERA, and I'll be moderating today's event. And joining me from AERA is Rob Monroe.
Good morning, everyone. Rob Monroe here from AERA. I look after membership and technical development, and looking forward to today's presentation on piston alloys and coatings. We're going to introduce both Scott and Ken here in just a little bit. And if you have any questions throughout the webinar, by all means, Amanda's going to show you how to use this questions box. And what we'll do is we'll save those questions for the end, and we'll get both Ken and Scott to answer those at the end of the presentation. So I'll go back over to Amanda. She'll just quickly show you how to use some of the toolbar functions, and we'll get going.
Perfect. Just a couple housekeeping slides for you guys before we get rolling. First off, there's a couple different ways to listen in to today's webinar. If you're calling in via phone, make sure you've selected the telephone button and enter your access code and audio PIN. And you can also listen in via your computers, mic, and speakers. And again, if you're doing this, just make sure you have that appropriate button selected so that your line stays muted during the presentation. A couple other things to know. There is a grab tab on the control panel. This is the little orangish box with the arrow in it. This allows you to collapse and expand the control panel during the presentation so it's not in the way if you want to maximize your viewing screen. And then lastly is the questions and chat box at the bottom. As Rob mentioned, if you have any questions for us, comments, anything during the presentation, go ahead and enter that in there, and we will be getting back to you during the presentation as well as doing a Q&A at the end. So at this time, I'm going to hand things back over to Rob and let him get going with the next part.
Super. Thanks, Amanda. Yeah, just a little bit of housekeeping here before we get started into today's webinar. For those of you that don't know who we are, AERA, we've been around since 1922. So we are a nonprofit association that represents over 2,000 members worldwide. Our members include engine builders as well as rebuilders. We have installers and part supply manufacturers as well as distributors that are all part of our membership. We have reps as well as schools and government agencies. Something that this slide, you can sort of mentions here, we really promote the idea of networking. We've got today's webinar is another form of networking so that we can all learn from each other. But we all learn from each other, and by getting together, especially like examples would be like our regionals and at PRI this year, we really try to promote the idea of getting together and networking, and that's how we do learn from each other. So again, looking forward to today's presentation. For those of you that are not members of AERA, some of the benefits of being a member are listed here. As a member, you do get specification manuals. So we've got 7 manuals that you get when you do sign up to be a member of AERA. We have our Engine Professional magazine. That is a quarterly publication that comes out that's got lots of good application-driven articles in there to help you out in the shop. The big one is the access to our toll-free tech line. We have 5 techs on that can help you with any of your technical needs and specification requirements. So that is another big benefit of being a member of AERA. And you have unlimited use of that tech line as a member. We have our online training program. We have an automotive machining training program to certify you as a machinist. We can help you out with that. We've got the Contingency Connection Rewards booklet, and I'm going to show you that here just in a minute. That will show you how you can actually save money with your membership and your process by using that rewards booklet. We've got special discounts from our corporate partners. You do get a trial of Process Pro when you become a member to have a look at, as well as there's also a demo version for non-members. Anybody on there today that wants to look at our software and see how that works, we can set you up to do that. So some of the benefits of being a member, we do have credit card processing. We have a savings program through UPS. We've got things like conference call program through Intercall, affinity program for our Canadian members that can help you with savings on health, dental, life, and travel insurance, as well as any of the shops out there that are looking for help. We've got Job Depot USA as a specialty job board, and they're one of our corporate partners and can help with finding machinists and get you looked after that way. Like I mentioned, the Contingency Connection Rewards booklet. This is a booklet that you can actually use. It's loaded with all kinds of coupons and savings in this booklet. The big one that you want to find though, and this will help you with your renewal, or if you want to become a member of AERA, right off the top, if you can save $75 on your membership by strictly using this coupon in this booklet. So real easy math can kind of show you here. I mean, a typical shop in the US is $399 for 1 to 3 employees. You take that $75 coupon, now you're only $324, and that's for the year, or we can break that up into a monthly payment of $27 per month. So really inexpensive to be a member of AERA, and again, we encourage you to use those coupons that are in that book to help save you some money. Just to give you an idea of what we're looking at for next year, we've already kind of laid down some dates for our regional conferences. So just looking at our tentative schedule, just so maybe you can make plans to get out to some of these regional conferences. We understand it's difficult to get out to some of the larger shows, and maybe you don't want to be away from the shop for that long. So what we try to do is we have these regional conferences. A lot of times they're only just one day, and sometimes they're, you know, maybe on a Friday or just before the weekend or on a Saturday, so that, again, we can get you out of the shop, but not for too long. And these are great networking opportunities. We have folks like United Engine Machine that actually come and exhibit at these regionals. And this is a great learning experience, and to be able to have a presence with our exhibitors and have a one-on-one and talk to them with not thousands of people there to do it. It's a great opportunity for you to learn. So looking at next year, we've got Motor State Distributing. We'll be out there on March 30th. That's out in Michigan. Sun and Products will be May 3rd out in Missouri. Bakersfield College, that's a California one, and that'll be on May 18th. And then next September out in Pennsylvania, we'll be at Liberty Engine Parts. So we try to do 4 to 5 of these regionals every year, so that, and we try to bring them just a little bit closer to maybe where you're located. So hopefully these will work out for you next year, and we can see you out there at some of these conferences. Next week is a busy week for both AERA and United Engine and Machine. This is the PRI show. So we're going to be out at booth number 5514. And we'll also be involved with the EUTECTIC conference. So that's December 4th through 7th. We will have a presentation on the Thursday. Chuck Lynch, one of our tech guys, he'll be doing a honing presentation. So we would encourage you to, there's no cost to that. You can just basically just make yourself available and check out that conference and check out Chuck's presentation. We'll also be at the Student Career Day on Friday, December 7th, which is right after the student breakfast. And we'll also have a booth there. So anybody that wants to come and see us and talk to us, by all means, this is where we're going to show you what we've got new for 2019. And we look forward to anybody coming by and saying hi and talking to us. So what I'm going to do now is I'm going to introduce both Scott and Ken from United Engine Machine. And both these folks, Scott is the president, Scott Sulprizio, and Ken Carter is the VP of sales. And it's nice that we can free these guys up. We know that they're busy and it takes time out of their day, but it's a great learning experience, and looking forward to the presentation. And again, if anybody has any questions, by all means, just throw them in that chat box and in the questions box there, and both Amanda and I will get these over to Scott and Ken. So good morning, guys, and thank you for putting on the presentation. How's it going this morning?
It's going great, Rob and Amanda. Thank you for this opportunity. I got to tell you, I don't even have a shop, and I want to join to get all that information that you have here. I'm having a little issue with trying to get the full screen here. Hold on here. There we go. There we go. I have to tell you, Rob, United Engine Machine appreciate to be a part of this webinar. Many of you on this call might not recognize the name of United Engine Machine, but you certainly recognize our brands. We offer the Silverlight OE version piston, the KB Performance Hypereutectic piston, the Icon Forge piston line, as well as our new dual alloy diesel presentation. Or pistons. Today, we're going to be talking about and reviewing the various piston alloys, their properties, and how they apply to your different applications. Additionally, we're going to review the coatings available and how they can enhance these alloys that we're going to discuss and how they improve the performance for your applications. Do you see that little box in the middle of the screen, Rob? I got a little box that's showing things here for some reason. Okay, I got rid of it. All right. Today we're going to talk about the eutectic alloys. Aluminum eutectic alloys it's a primary metal alloy for almost all internal combustion engines, whether you're looking at 2-cycle, 4-cycle, or medium-duty diesel applications. Now, the main alloying element that we're going to be discussing is silicone. And that's what we're going to be focusing on. And why? Because silicone, when added to aluminum, provides low thermal conductivity, which means it inhibits heat transfer. It also has low thermal expansion, which reduces the metal growth in the piston. And also, because of the silicone particles, it adds a lot of wear resistance because of the hardness of that element. Now, common eutectic alloys for pistons. You guys have heard hypereutectic. May have heard hypoeutectic, but basically we're talking about eutectic alloys. And when silicone is added to aluminum, it becomes in balance at 11.7%. And to sort of put that in perspective, you got an auditorium with so many seats. At 11.7% of silicone, all those seats are filled and everybody's happy. Now you can change that by putting less, and that goes out of balance. That's called hypoeutectic. And then if you put more than 11.7% by weight of silicone into the mixture, then it's hypereutectic. And there's different qualities that are added to those different alloys. But keep in mind that there's a balance factor at 11.7%. There's also a solidification variation, and it differs depending on whether the metal is a pure element or if it's an alloy. And I got to tell you, this is interesting. It's almost counterintuitive as a fact. Here's an example of solder. Solder is made up of tin and lead. At 60% tin and 40% weight, that's eutectic. And if you notice here, if I'm highlighting it, tin will melt at 446 degrees Fahrenheit and lead at 626 degrees Fahrenheit. You put them both together, and it changes with that combination of both elements. And now it melts at 338 degrees Fahrenheit, 100 degrees cooler. Now looking at the eutectic piston, where we're talking about aluminum and silicone, at 11.7% silicone and 88.3% aluminum. Aluminum melts at 1220 degrees Fahrenheit, silicone at 2552 Fahrenheit. You put both of those together, and then it melts at 1070 degrees Fahrenheit. That's 150 degrees cooler. Again, it's counterintuitive because you would think it would pick one or the other or the highest one, but it's not. It reduces the actual. So a common out of balance condition rather for hypereutectic and hyper. I mentioned you're going to hear this often, 11.7%. That means everything in balance. All the rooms in the auditorium are filled. At hypo, it's under 11.7. It's a little out of balance. And on the right, there's too much silicone, so it's hypereutectic, and it's out of balance as well. Now, the importance of this comes into play in the solidification process. After you pour the molten alloy into the mold, the primary phase of cooling elements, which is causing the imbalance that we just talked about, will form in solids first. Now, as far as the out of balance element, it will continue to solidify, thus lowering its percentage in the molten liquid. It'll become a little bit clearer in a couple slides here. This process will continue until it reaches that equilibrium balance point of 11.7%. And then at that point, it solidifies like a pure element. Now here's a slide that looks a little like there's too much into it. But on the left here, you see these are different phases of solidification. So it's poured into the mold here. And as soon as it's poured, it starts losing its temperature. And it gets down to this line here. This is 1,070 degrees. And at this point, this is eutectic, so there's 11.7. As soon as it gets to that 1,070, it solidifies as a pure element. And on the next slide, you'll see that imbalance. Here's a hypoeutectic. We don't have much silicone in it. So the aluminum that's in that molten material will actually solidify first until it gets to the equilibrium point of 11.7% silicone. And that shows the line of solidification. And the next one is hypereutectic. And that actually starts, as it starts to cool, the silicone being more than 11.7% will solidify first. And it forms, as you see up here on the right, it forms those little nodules of silicone first. And that's important to the hardness factor when we start cutting grooves in that. And as soon as it reaches the equilibrium point after it solidifies the silicone, 11.7%, 1,070 degrees Fahrenheit, it solidifies the whole piston, and that will put us into the next slide.
Hey, Ken, can I say one thing there?
Yes.
A lot of people think that the silicone is just, on the outside, but it's throughout the whole metal. So it's when it forms, these particles are forming throughout the whole piston. And I think you'll show how that affects on this next slide here.
Yeah, right. So here's a hypereutectic cutaway. Here's a simulated ring groove. And here's a electron microscope view. They see this primary particle of silicone right here. And that's the silicone's a harder material. And so that provides the hardness, not just throughout the piston, but also in the grooves where the rings are. And so it's an important as far as a wear surface is concerned. Now, the characteristics of silicone. Why is it added? Obviously, there's a few things that are important. Ductility, which is the tensile strength, the malleability. The lower the silicone, the more ductile that piston is. And it can absorb the shock a little bit better. The lower tensile strength allows it to absorb, especially in high compression, high output engines. It also affects the thermal expansion. The more silicone in the material, the less metal growth it has. And thermal conductivity, basically, it has thermal characteristics. If it doesn't conduct the heat, it keeps the heat up into the cylinder. And we already talked about the hardness and the wear reduction. This line might look confusing, but actually should help with the understanding. At the far left is the lower content of silicone. We show our 2618, which, by the way, is the same basic material alloy that most all piston manufacturers use, has less than 0.23, less than 1% silicone in it. And that's always in a forging, and that's left on the silicone content line. So it's very ductile. It can absorb the shock. It will expand more because it doesn't have the silicone in it. So you'll need more clearance. Typically, a 2618 forged piston, we build in the 4.5 thousandths clearance right into the piston skirt so that it's already accounted for. It will allow thermal conductivity. It has lower wear resistance. So you're looking at this and you say, well, why would I want that? Well, for the high output engines, and we'll discuss that in a little bit later. You move up the silicone line, we have one casting alloy that's there, and also in our performance, we have a 4032. That's both in our Icon and our FHR forged pistons. That 4032 has about 12% silicone in it. So it's right near that equilibrium line that you see right here in red. That's 11.7. And then it moves on to the higher hypereutectic versions, such as our 390 cast. And that's typically, in most piston manufacturers, have 14 to 16%. Now, when you have that higher silicone, again, I'll be repetitive, you have lower ductility. It's a higher tensile strength, a little bit more brittle if you want to look at it that way. You can have tighter clearances on the skirt because it has a lower expansion property. It maintains its shape without growing. It has low thermal conductivity, so it keeps the heat up. It has much higher wear resistance, and is quieter since it doesn't have the clearance, which could provide some piston slap into it. Now, I'm going through this pretty fast, but we can answer questions later. Basically, there's no alloy that gives you the best of both worlds, high ductility and great thermal and wear properties. It just doesn't exist. But within that line, most applications can be accounted for. And as we'll talk in a little bit, the coatings that are available can also help adapt those alloys for your actual application. Now they have each, as I talked about, there's different characteristics. How can we apply these to the application side of things? This looks like, again, a busy slide. I put this together. It's a basic selection guide. Over here on the left are our different products, and it has the different alloys here. Their alloys are explained in this part. But you go from standard service applications, just like the OE replacements, light trucks, moderate street performance, all the way over to the high compression boost and nitrous race applications. And you can see that it moves the acceptability line down to the forged 2618 alloy right here as the best solution for it. But it gives you different options in the various levels of applications. And it's all based on the properties that we talked about as far as the silicone imparts. So this was just like a cheat sheet that I had put together. Looking at a few of the actual applications, here's a 383 Chevy. It's injected, 10.5 to 1 compression. There's the head volume, and it's a 5.7 rod, all very popular. One of the options, and one that works for the performance side, is again the 4032 alloy. For it has 11% silicone in it, so it maintains some of the heat characteristics for thermal, as well as medium ductility. The FHR I'll describe in a little bit, but it also has our new standard M42 coating on this. So that's just a street performance typical piston. There are other options. You could use Hypereutectic cast, but this is just going through a few examples. Here's the popular LS 6-liter injected engine, level 1 application. Again, about 10.5 to 1 compression, moderate to high boost. There's the cylinder head. We're suggesting, and I have this offering for a 2618 alloy, which is the low silicone content, so it provides high ductility, and it is anodized, provides some thermal protection. We do this in-house in the M42 coating. This is just, and we'll talk about some other things, but if you have any questions for your specific, we'll provide our tech service, which are great guys. They can help you out specifically with it. Many of you already know these things. I'm actually just trying to explain it for those that might not be as abreast of all this. On level 2, high performance, here's a 540 big block Chevy. We're suggesting the 4032 alloy. again, the medium silicone, about at the eutectic stage. This provides the medium ductility and some thermal, and again, our M42 coating. Now, on the big bad boy here, where you get nitrous action, the 565 big black Chevy injected, you go to the 2618 alloy, the low silicone. It gives you high ductility. It can handle those concussive forces and the pressures that build up in that race application. And although it's not shown on this piston, there's a thermal barrier, metallic ceramic coating that can be put on here to help keep even more heat up into the cylinder. But this one is anodized, and this anodizing provides some heat barrier as well. And this one, and we'll talk about it more length, is our new adaptive coating, line-to-line coating that we offer on any of our pistons. Now, here's sort of a disclaimer, and it's about the importance of proper tuning. And if you look at the OEs, they're like the world's best at it because that's all they do, and that's all they're focused on. And their one particular engine could be a high output, but they'll use they'll just use cast pistons in it. And they do it because of the tuning, that they make sure that the air fuel mixture, the time, everything is there that can not destroy the cast piston. It doesn't have to go to a forge because of the cost. So no matter what alloy you use, no alloy can survive a bad tune-up. That's very important. And as far as horsepower goes, as the horsepower goes up, it's even more critical on the tune. And I know I'm preaching to the choir, but any of you that have had a bad tune and have an engine breakout on you, it's something to be concerned about. So here's a little bit of trivia. That 2618 alloy that is ubiquitous today with everybody was actually produced during World War II for the Rolls-Royce engine and a Spitfire engine. I mean, that was done all the way back then, but it's still very doable, usable, and has all the qualities that we need today for our race engines. So I think that's pretty interesting. Now, how do we overcome some of the limitations that we talked about on the alloys? And that's where you have the 2618, it's more malleable, but there's a lot of skirt clearance there that provides some piston knocking and things like that. Well, we're going to go through some of the piston coatings that are available. Ours that we're going to talk about are fairly demonstrative of what's available from our competitors as well. One of the things I wanted to point out that virtually all of the coatings that we produce for our pistons, we do in-house. We've made that investment. Let's go to our standard coating, the M42. Now, most standard coatings, even including our old coating, the Dow 10, just included graphite. That's a lubricious material. It provides protection for once you put the engine together and all the parts start melting together to produce a good film of oil and break in. Well, our new coating, which is now standard on all of our performance pistons, both the KV and the Icon, they include 3 lubricious components: the graphite, Teflon, and molybdenum. So it's no longer a break-in coating. And some of our competitors have similar ones, like Mala has Grafal, which is a great coating as well. But this is like the state of the art with these 3 elements combined. That is more than a break-in coating, and it provides protection well past the initial break-in of the engine. And obviously, it does what you're expected to do, and that's reduce the engine wear, decrease the piston slap, horsepower, fuel efficiency, all that, because of its lubricious nature, and protects from scuffing and scoring. Now, to demonstrate how wonderful this coating is, and I'll just focus down here on the bottom right. Before we can talk about competitors, actually one of these, competitor A, B, and C, used to be our old coating as well. But our new Ultaware has, with those three lubricious components, provides a little more, it reduces friction. But here's the key: before our coating will degrade on PSI, it's 3 times what it used to be, and the thermal stability is about 3 times what it used to be. So again, it's not just for braking anymore, and this is on all of our. It's our standard coating. Anodizing, it's a process. It's actually a conversion coating. It's not sprayed on or screened on. It actually converts the metal, as you can see here, and depending on the alloy, it has different coloration effects. And typically, we, as well as others, we anodize the top crown and the first ringland, and that's important because the hardness of anodizing, which we'll talk about, provides some real protection against micro welding in that. Now, I said it was a conversion coating. Anodizing actually, through the different baths, there's about 8 of them it goes through. It actually produces into the material, the base material, by about 1,000ths, and it builds up on top of the aluminum by 1,000ths, and that's actually corundum, which is aluminum oxide. Corundum on the hardness scale is just below diamond, which is the hardest natural substance we have. And so aluminum oxide provides a very strong, durable, hard surface. And yes.
Ken, let me just throw something in. This is normally considered type 3 hard anodizing. So there's type 2, type 3, and type 2 doesn't build up. It just goes in. Type 3 does what you say. It builds up and goes in. So what we're applying is called type 3 hard anodizing.
Terrific. Thank you for that clarification. And what it does, that hardness obviously provides some abrasion resistance for wear, especially in on the top ring groove. And because of the micro welding, now micro welding is basically where similar materials under pressure and high heat will actually form a temporary weld, and actually it pulls off a piece of the aluminum and puts it on the ring. And so once that goes on there, it adds more friction, and the heat and pressure adds more micro welding to where the ring won't seat well on the top ring groove. So this eliminates that if you've had any of those issues. The other benefit for anodizing is it provides another level of thermal barrier. It's not conductive, so it keeps the more heat up into the cylinder area. And now, if you want real thermal barrier protection, you go into our Ultratherm, and this is a ceramic thermal barrier that we produce in-house. It provides the most benefit to keeping the thermal conductivity from going into the piston below and into the oil, and increase the temperature of the engine. And it basically not just deflects, it just keeps the heat up, and it's the state of the art. To demonstrate that, we actually took, in this video I think can be accessed on our online, we took an acetylene torch, which goes between 3,600 and 4,000 degrees Fahrenheit, and in 31 seconds, you can see here on the left, without the Ultratherm barrier, it burned a hole right through. It just melted the piston. And in the same time frame, all you see here, it did not melt through, and there's residue on top of there from the acetylene torch material, but it protects the piston very well. And this is particularly a benefit for the high horsepower. Now, here's the coating that is really starting to get some traction in the industry. This is an adaptive skirt technology. We're licensed by our partners in Line to Line up in Michigan. It's an abradable coating. Now, I mentioned before that on our forged pistons, there's about a 4,500 clearance on the 2618. This technology is it actually can be put on in different thicknesses. It's a graphite type coating that we spray on to the skirt and take up that clearance. Now we typically take up 80% of the clearance. So on a 4.5 thousandths, we'll put about 3.5 thousandths on it. So it takes up most of that clearance. Now by taking that clearance up, when you install the piston and it starts operating, it'll actually hone in and individually adapt that piston to that individual cylinder. And as soon as it has clearance for oil, it stops abrading and goes from this picture here on the left, that's prior to break-in, and this is after break-in. Now, interesting, all these little dark squiggly lines you see there is actually trapped oil. They're oil reservoirs throughout the full surface of that abradable coating. Now that provides an additional lubricious component, obviously, that stays there and stays in place, protecting the reducing the friction and everything else. But because it adapts that piston to the cylinder, it keeps the piston square to the bore, which means the rings are square to the bore, and that the rings can do their job much more effectively in keeping the combustion pressures up, reducing blow-by. It reduces it takes away the piston slap noise from those applications. Additionally, it was through testing by our partners, it actually reduced the shock load that affect the bearings that the rods were attached to. So it also does that. There's some other benefits. On the right here, you see where a typical liquid coating, the typical standard coating, has the load area here, a high load area in red, a little bit lower load area here in the brown, and it doesn't really attach much into the green area. With this new abradable coating, that adapts that piston to that cylinder and spreads the load out of a greater area, reduces or eliminates the high load area, and you can tell just by doing that, it reduces the friction. So,
hey, Ken, can I say one thing?
Certainly.
We like to refer to when the material is honed in, we call it a non-geometric oil film, because as you can see, the oil pattern is random. So there is no ability for the oil to be driven off the face of the skirt. So the adaptable coating has what we like to consider a kind of a non-geometric oil film. And you can see the randomness of the oil pockets. There's no straight line for the oil to migrate off the skirt.
Yeah, that's a good point. In fact, those of you that are familiar with moly-filled top rings, the reason why those work so well in today's engines is not because of the molybdenum that's in that ring face is there, and that's harder. It's because of the trapped oil, because it's a porous material. And so the molybdenum rings actually are like our skirt technology, adaptive skirt technology. It traps the oil, which is important for lubricity and long life. Okay, here's a few offerings here. This is the FHR formed head relief, it's called. This is a Icon piston that's forged. It's the 4032 material. It is more for the economy budget for the race enthusiast. We have those available. We have the premium forge. It has the fully machined heads, and we have that in both the 4032 11% silicone or the 2618 less than 1% silicone. And that's for, we also have other features in it. Everything is precision CNC. No, by the way, all of our skirts are produced on CNC machines that have tolerances to 1/10,000ths. It's all in a controlled room environment at 70 degrees. So that reduces any variation in the machining, as well as the sizing of those pistons. And also in our Icon Premium, We have pressure-fed pin bore oiling and skirt and pin boss struts for additional strength and durability. We also have our Elite icon, and this includes our line-to-line abradable adaptive skirt technology that you see here, and also includes our anodized top. And we also have gone one step further for some specialized applications. The real high output, we have the Icon LCAT, which has all those features and also adds the thermal barrier, ceramic metallic, as well as the anodizing and the adaptive skirt. So this is all available from us, and that I've gone through very quickly. I'm sure we have quite a few questions. I wanted to point out that for personalized individual attention, we have a terrific tech service department. These guys know more and have forgotten more than I'll ever know. And that's the number to call. There's the hours. You can contact them online as well. But these guys can answer a lot of your other questions. I know I've gone through this rather quickly, so I guess I'm ready for, we're ready for questions. Rob, Amanda?
Super. Yeah, no, thank you very much, guys. Great presentation. It's nice when, like I mentioned before, I mean, it's difficult for everybody to get out of the shop to take part in any kind of professional development. So anytime we can get together and do this kind of thing, it really helps us. So I do appreciate it for sure. Couple questions have come through here, and I'll just open them up here real quick here for you. So here, first question that's come in, what applications would require a 2618 alloy?
Well, Scott, I'll let Scott answer that, although it's really the 2618 has, it's more malleable, so it's really for the high boost, high output engines. But Scott, you might want to add something to that.
No, I think that's correct. I do think that piston choices are more difficult. And again, I go back to your slide on, controlling combustion and how the OEs are taking cast pistons up to, 500, 600 horsepower type stuff. But I think traditionally that's the right answer, is that as you move up in horsepower and you move up in demand, that the 2618 offers great ductility. And so that seems to be a very preferred piston by many racers.
Okay. Another question that's come in is, if you're coating a 2618 piston, does wall clearance stay the same? So they've used an example, if you've got 4 thou before the coating, does that seem to matter with as far as clearance goes?
Well, I'll answer that. The clearance we build right into the skirt. So like I mentioned, on the 2618, it's about 4.5 thousandths on average. For the 4032, it would be less because it doesn't have, it won't expand more. You got to provide the clearance for that piston to expand under when it gets up to temperature. But all the coatings are standard coating. It will not affect that. You don't have to change the clearance in your bore size. And certainly on that adaptive line-to-line coating, it adapts itself, so there's no reason to worry, and it's perfect for it. So you don't have to do anything else on coated pistons, whether it be ours or anybody else's. It's already built in the specs in manufacturing.
I will say one thing on the line-to-line adaptive skirt, that when it creates an oil film, it stops wearing. So the material that has not been worn away is left there to stabilize the piston. So when we say adaptive skirt, each cylinder is going to fit itself. And so the amount of coating that is used by each cylinder is really based on that cylinder. The other thing I will say is where the M42 a harder coating. It's going to only be about a half a thousandth thick, maybe even a little less than that. So fitting it into the motor, you're still going to have the larger clearances. But the adaptive coating will wear in and stop wearing. Now, the one thing I will say is the adaptive coating, if the engine sees further distress, will re-abrade itself to the new condition. So it's kind of an interesting thing. It's very possible if the engine goes into total distress for the coating to completely abrade itself away. But that's a rare condition. We really haven't seen much of that, if any of that. And so the real benefit is one coating is non-elastic in terms of its filling up clearance. The other coating is totally elastic or totally will adapt itself, and it will leave residue behind to help stabilize the piston. So back to you, Ken.
Yeah. Any other questions?
Yeah, we do actually. Questions are coming in, and like I say, if with all the questions that are coming in, if we do run out of time here today, because we are going to kind of cut it off pretty close to an hour, both Ken and Scott are available to answer these questions, and we'll just forward those questions to them, and they'll get those answered for you. So another question's come in is, I've got a new set of Icon forged pistons that have no coatings. Can these pistons be shipped to the factory and coated, and would that be cost prohibitive?
I'll let Scott answer that.
Yes, they can be, and yes, the coating is more expensive, you know, but I don't know how you say what means cost prohibitive. So it depends what you're trying to gain. But yes, the answer is yes, it can come back. And I think for what you're getting, the value that we put on, I wouldn't consider it cost prohibitive. But I will say one thing. The thermal barrier can be put on as an afterthought. The abradable coating can be put on as an afterthought, but anodizing cannot because it's a conversion coating. So the top groove is actually adjusted for that conversion coating. So in the case of sending it in either for thermal barriers or skirt coatings, those can be done as an afterthought, but the anodizing cannot. It has to come as part of the finished piston.
Alrighty. Another question in regards to coating, is the piston machined differently when the line-to-line coating is applied from the start?
The answer is no. It's machined the same.
And the beauty of the line-to-line is, since it is abradable, it's adaptive, and it will adapt to that cylinder. So it'll wear more in some areas, less in other areas. And as Ken's slide showed how you see that larger wear pattern, the other thing about the adaptive skirt coating is it'll also take the friction to its lowest point. So as it wears in, the friction starts dropping precipitously down to the lowest point. And when it creates that point where there's the oil film, at that point you're at the lowest point of friction, and the skirt is adapted to its condition in that cylinder. So in essence, it's like custom fitting every piston to each cylinder.
All right.
Okay.
Another question's come in. They're asking approximately when, they're looking for maybe a date, did the M42 coatings become standard? This particular person recently purchased a set of Icon forged 2142 pistons. They had the black coating. They're building the engine now and pistons installed. So just wondering about.
I believe if he's got coating on that piston, it should be the M42 coating.
Yeah, everything produced, all performance pistons produced after March of this year, early this year, will be coated, and if it has a coating on it, it would be M42.
Okay, all right. And another question that's come in is, will the worn coating be stopped in the oil filter, or what happens with the coating after it dissipates?
Great question. The adaptive line-to-line coating is actually a graphite, so it's a lubricious component and will not affect anything. It actually goes through the filter, stays emulsified in the oil from what I understand, and it provides no harm. You don't have to change oil filters or anything else different than you do anytime. It's just it's its own lubricant.
Okay, all right. And then a question here in regards to clearance again. So are pistons with the adaptive coating installed initially with no clearance? They've used the example as GM started using interference pistons a few years back.
Let me take that. This coating is a little counterintuitive to what people have always figured, because they always believe there has to be a certain clearance. Technically, what we're doing is we're eating up that clearance, and then we're allowing the piston to fit itself backwards. So the clearance that's built into the piston is the clearance. The coating goes on to eat up, like Ken says, about 80% of that. And then as it adapts, it'll leave behind the clearance that it needs to operate. So it's not something that they need to be concerned about. But the initial clearance, the 4,500 is still built into the part. And the 80% coating that goes on is there. And what, depending upon the operation in the cylinder, depends how much coating is left behind. And again, at that point, you get the benefits of the adaptive skirt. You get the fit, you get the low friction, you get the oiling, you get all of those benefits of adaptive skirt technology. So the piston has its own clearance. The coating will fill it up about 80%, and then it will work its way back. As soon as it creates that oil film, it'll stop, and that's the clearance that's left in the piston based on its operation.
Let me add this, Scott. Early on, a lot of the pistons we were looking at, we did add extra coating thickness to take up 100% of that clearance, and those were a little bit more difficult to fit. And we found that by just putting 80%, taking up 80% of that clearance, you got 95% of all the benefits of that. Obviously, if it was full, if we took all of it, then there was longer time for adapting, and there wasn't as much benefit or ease of installation by going to 80%.
All right.
I hope that answers the gentleman's question.
Yeah, no, for sure. I know on the tech line, you know, we do get these questions about, you know, coatings and clearance, and when we see an interference clearance, it's sometimes that's when the questions start coming in. You know, why would I fit a piston at an interference? But no, these are really good answers. It's stuff that, like I say, on the tech line that we get all the time, so we appreciate that.
And that's why we went to the term adaptive skirt technology, because it's more descriptive of what the coating does. And I think there's a thing, if someone wants to get more involved with this thing, there's a thing called the Strybeck curve that talks about the science behind the coating. And so if someone is more interested in that, I think we're going to have something up on the website coming up on the Strybeck curve. But you know, it's a little dry. It's a graph, and it's other things, and it's the tribology kind of behind the coating, and it's the science behind the coating. So yes, we talk about adaptive skirt and how it fits, but if they're interested a little bit more in the science, I'll be happy to send them a copy of the Strybeck curve and how it's applying to the adaptive skirt and line-to-line coating. Or we'd be happy to talk to them a little bit on the phone and go over that with them, how it works. So I think it's one thing for us to talk about all this adaptive and how it fits, but if they really want to see a little bit of the science, and the Strybeck curve is it goes back into the early part of the century. And it is like I said, the tribology of two sliding surfaces and how it works and how the coating fits itself and how it actually gets to this lowest point of friction. So we'd be happy to supply any of that information.
Yeah, the engineers would really enjoy it.
Oh, super. that's great. We appreciate that. And like I say, anybody out there that wants to see that, let us know, and we'll get Ken and Scott to get that over to you for sure.
And also line to line, if they care to, they could contact line to line directly, and I'm sure that they'd be happy to talk about the Strybeck curve. And I think line to line also has a little video on that, and so but it is the science, and I think that's what's important. We throw out a lot of terms, but adaptive skirt technology says a lot, and there's a lot going on, and many times we put a coating out like M42, and you have a little bit of idea about what M42 does, but I think the Strybeck curve gets you further into why this adaptive skirt and how it works and how the benefits come to them would show up on the Strybeck curve.
Okay, yeah, no, thank you. So like I say, anybody that's got any more questions, we'll get those over to Ken and Scott here, and we'll get them answered for you. We're kind of creeping up on the hour here. We know everybody's busy and get back to work and start making money in the shops. Both Ken and Scott, I want to thank you for today's webinar. It's very, very insightful. Again, on the tech line, we get these questions all the time. So your presentation today hopefully answered some really good questions for everybody. We appreciate your time. We know you're busy. And for anybody that's out there, these guys will be at PRI next week. So if you're over there, make sure to stop in the booth and say hi and say hi to everybody. So what I'm going to do now is, again, appreciate it, guys. I'm going to bring Amanda back on the phone and just do a little bit of housekeeping here for you real quick, and we'll get things wrapped up. Hey, Amanda.
All right, thanks so much.
Thanks, guys.
Yeah, thanks again. Just a couple, like Rob said, housekeeping things, just so everybody knows. You will see a survey pop up when you leave the webinar today. Please take a moment, fill that out, let us know how we did. If you have any follow-up questions, there's a spot in there to ask those questions as well. Tomorrow you will get an email with a link to the recording of the webinar, and you can use that at your discretion, pass it along to colleagues, friends, rewatch it yourself. It's yours to use. You'll also see our contact information is listed there. You can contact any of us with any questions you have, and we will definitely pass those along if need be. So once again, thank you, you guys, and thank you everyone for taking time out of your day to watch, and we hope you have a great rest of your day.
Thank you.
Thank you.
Thanks, guys.